In this video, we are going to discuss about the PN junction diode and current equation. First, before that, let us see what is a semiconductor. A semiconductor is a material which has the electrical conductivity to a degree between that of a metal and that of an insulator. It acts as a insulator, partially insulator and a partially non-conducting materials. So these transistors, solar cells, light emitting diodes, quantum dots and digital and atom integrated circuits these are the foundations of the modern electronics which comes under the semiconductors. And here let us see the types of the semiconductor, that is intrinsic semiconductor and extrinsic semiconductor. In the case of the intrinsic semiconductor, which is very pure, that is impurities does not depend or does not affect any electrical behavior, because it has equal number of electrons and holes, and also the electrons and holes flows in the opposite direction in the electric field, so that they can contribute to the current in the same direction since they are oppositely charged. And extrinsic semiconductor are completely it contains impurities. The impurities are added to the intrinsic semiconductor to make it strong, to modify the number and the type of the free charge carriers. So this extrinsic semiconductor is a semiconductor that has been doped, to which the semiconductor which gives different electrical properties than the intrinsic pure semiconductor. And in the case of the intrinsic semiconductor, there are of two types. One is N-type semiconductor and the P-type semiconductor. N-type semiconductors are the electron concentration will be higher than the hole concentration, and in the P-type concentration it is vice versa, that is hole concentration will be higher. And what is PN junction? So when comes under the PN junction, we know it is having P and N semiconductor materials which is jointly together, and there exists some kind of junction which we call it as PN junction, and the donor impurity begins to go to the acceptors and the acceptor goes to the donor. So there will be a channel, or there will be a junction in which the donors and the acceptors will join together to form the junction which we call it as a PN junction. So here the total charge of the junction will be equal and opposite to maintain the neutral charge condition around the junction. If this depletion region distance has a distance of d, then it migrates towards the distance at the positive side and the negative side, which gives the relationship as dpna equal to dnnd. So you can see in this figure, you can see the diffusion region. It is considered in the N region, P region, and when the electrons and holes are moving in the opposite direction, then the center region forms a diffused layer and forms a PN junction. So as this N-type materials has lost the electrons and the P-type has lost the holes, this N-type material becomes positive with respect to P-type. So here you can see the impurity atoms which has been added to the junction, so that creates some problems of the free charge electrons, and it gains some extra energy to overcome the barrier from the depletion region. So for this we have created a diffusion process that we call it as a built-in potential difference, which the open circuit, or we call it as a zero bias potential. And depletion region PN junction, if one type of the crystal pure semiconductor is doped with the acceptor impurity atoms and other is doped with the donor impurity atoms, this can be called as the depletion layer PN junction. And here during this process there is a junction which is forming in the N to P and P to N. These combine to form a layer in which the region which is formed in between this furnace does not have any mobile charge when close to the junction. So that's why we call that as depletion region. And the left side of the junction there will be the acceptor atoms, and the right side it will be having the donor atoms, which we call it as positive ions. And what is the function of depletion layer PN junction? First, an electrical field is set up between the donor and the acceptor ions in the depletion layer. So the potential at the N side is higher than the potential at the P side. The electrons in the N side are prevented to go to the lower potential side. Similarly, holes will be coming to the N side, so there creates some barrier, and the difference between the barrier is called as the potential barrier. The barrier is approximately 0.7 for silicon and 0.3 for germanium. And this is the current equation. For deriving the current, we use the equation as I is equal to I naught into e power v by eta vt minus 1, where I is nothing but the diode current, I naught diode reverse saturation current, V external voltage, eta constant, Vt kT by Q, and K is the Boltzmann constant, Q charge of the electron, T temperature of the diode function. And here are the some equations for the germanium diode, silicon diode. Thank you.